This is number 2, Math 181, Calculus, Optimization Problems. Number 2 says, find the dimensions of a rectangle with area. So this time we're given the area instead of the perimeter. And notice it's square meters, whose perimeter is as small as possible. So we need to minimize the distance around the rectangle. And what is the minimum perimeter? So I need to think of minimum perimeter. That's what we're doing. Last time we maximized area, now we're minimizing perimeter. So my objective is to minimize perimeter. So I need the perimeter formula. P equals 2x plus 2y. That's your primary equation. Now this is a function of 2 variables, and I need it to be a function of 1 variable. So you use the other information in the problem, which is that the area is 1,000. So area is x times y, and I set that equal to 1,000. You solve for y, you get 1,000 over x. Now we're going to plug that in to our perimeter. So when I put that in for y, I get 2x plus 2 times 1,000 over x. And that means that p is equal to 2x plus 2,000 over x. And this is p of x. This is a function of 1 variable. Up here it was 2, and you always solve for y in the secondary equation. And then you put it back into your primary equation. Now we're going to take the derivative. Now, before I take the derivative, and notice I'm writing p of x, not p prime yet. I'm going to put that x up here so I don't have to do quotient rule right there. It's too little to do quotient rule. Plus, whenever you have a constant in the numerator, sometimes you can rewrite and just do product rule or just take the derivative. Right here, I don't even have to do product rule. The derivative is 2 minus, and bring the negative 1, multiply and subtract 1, and I get negative 2. Now I'm going to set that equal to 0 and solve. To set that equal to 0, I'm going to put this in the denominator. Then I'm going to put that to the right. I cross multiply. So you can think of this as 2 over 1, and then do kind of a cross multiply. So 2x squared equals 2,000. So divide by 2, take the square root. You get plus or minus the square root of 1,000, but we're looking at x is the side of a rectangle, so you only need the positive, and I'm getting x is about 31.6 when I put that in as the square root. The second derivative test, just to show you, take the second derivative up here. So the derivative of 0, 2 is 0, and then the negative 2 comes in front, and multiply by the 2,000x to the negative 3. And I wrote, oops, correction. You get to the negative 3rd power, and then you can plug in that 31.6, and that'll give you a positive value, which means concave up, which is a minimum. And now we've figured out, so you want to get to this value here. And that is the number that's giving you the minimum. And what was the question? Let's go back. Find the dimensions of a rectangle, so that's the length and the width, with a fixed area whose perimeter is as small as possible. So we found the x, and this is a rectangle, so we need to go back and find the y, and your y can be plugged back into right here. So 1,000 divided by 31.6 gives you another 31.6, so you can plug that in. Okay, and I'm going to write my conclusion. The dimensions are 31.6 meters by 31.6 meters, and the minimum perimeter is 126.5, and this is in meters. Perimeters measured in meters. It's not the area, it's the distance around. Now, how did I get that? I took 31.6, and you just multiply those together because it's length times width, or you can plug it into the perimeter equation above. All right, I'll be back for the third problem.